and the days go shorter, Pennsylvania is gearing up for a winter that could be influenced by a powerful climate phenomena, La Nina. This recurrent event, rooted in the Pacific Ocean's temperature patterns, is more than just a weather pattern. It has real implications for the season ahead. From extreme warmth to snowstorms, La Nina's impact on the winter may be significant.
But essentially, La Nina is the cooling of the equatorial Pacific sea surface temperatures, um, dropping below threshold that we use to classify either El Nino or La Nina conditions in that part of the ocean, Pacific Ocean.
Sea surface temperatures, the temperatures of the very top layer of the ocean, are measured globally using satellites and buoys. This data allows weather forecasters to track the development of El Niños and La Niñas, helping them to issue seasonal forecasts that extend far beyond the typical 7-day outlook seen on TV or online. Most seasonal forecasts are based on analog forecasting. This method involves comparing current weather conditions with patterns recorded from the past. When it comes to La Nina, forecasters have a wealth of historical data to draw from, allowing them to predict what a typical La Nina winter might look like globally and right here in Pennsylvania. So what do the analogs tell us that winter will look like with the La Nina present?
Just looking back at past La Ninas, precipitation has averaged very close to normal, and then snowfall has been more often than not below average, factoring in the past La Nina seasons. So, and I think that's also the if you look at like the outlooks from the Climate Prediction Center, very similar in the tilt and the odds, slightly toward above average temperatures, slightly toward above average precipitation. But also that signal as you go further to the northwest toward the Great Lakes, that's the most likely area that would see above average precipitation in the La Nina pattern given the storm track.
La Nina affects weather patterns by changing the trade winds around the equatorial Pacific, which can lead to a more wavy polar jet stream.
We do see more shifts, significant shifts in the jet stream pattern during the cooler months, to where in the warmer months, like you said, you kind of see a more relaxed or general west to east flow. In the cooler season, you get more meridional or north-south dips, troughs or ridges in the jet stream that have obvious impacts on weather systems and where they develop and how strong they can be over the cooler months.
A more wavy jet stream often means stronger storms, but their impact can vary widely. Contrary to what may be expected, a stronger snowstorm might not mean more snowfall.
And a lot of that has to do with a storm track that would be from the Ohio Valley up through the Great Lakes or to the west of Pennsylvania, which we see oftentimes develop in La Nina. So whether or not that pattern develops this winter remains to be seen. But historically, that's a favored storm track, not particularly great for snowfall in central PA. But we'll have to see how things evolve this winter.
This particular storm track isn't ideal for Pennsylvania snowfall because we'll end up on the warm sector of the storm, the southeastern side, where temperatures are often too high for snow. The ideal snow-producing track would be to the east of Pennsylvania, placing us in the storm's cold sector. This is where most of the snowfall occurs during a winter storm. So, what are the forecasters saying this year will look like with the La Nina likely to develop? Meteorologists at the Climate Prediction Center, a part of the National Weather Service, are predicting warmer than average temperatures and above average precipitation for Pennsylvania this winter. But remember, La Nina's history shows that these predictions can vary widely depending on other factors. And, as with any weather forecast, it can all come down to one significant event.
Yeah, that's right. It could only just take one to tip the scales, toward above average or below average snowfall.
For example, last winter in Allentown, snowfall was only at 31% of the average by February 12th, but just one major snowstorm on February 13th brought 9 inches of snowfall, significantly reducing the deficit. Yet, despite that storm, Allentown still ended the season 5 inches below average, highlighting how unpredictable snow totals can be. That is why when issuing a seasonal outlook, forecasters shy away from predicting exact precipitation totals. It is easier to predict above or below average temperatures and precipitation, but much harder to predict certain values. It is also very difficult to predict snowfall totals, as forecasting for snowfall is still very challenging even a few days out, let alone an entire month. This is because everything has to go just right for a snowstorm. If one variable, like surface temperatures, for example, are different than what is expected, it can completely mess up a forecast. La Niña is just one piece of the complex puzzle that meteorologists rely on to predict long-term weather patterns. Each factor plays a role, and it's the combination of these elements that creates a clear puzzle for what's ahead. Just like in the puzzle, every piece must fit together to reveal the full forecast. For Weather World, I'm Daniel Weaver.